One of the things I wanted to talk about is water. And here we're in a forest, and there's trees going down, and there's clouds up there in the sky, and lots of people. You see all that, right? So, what I want to talk about is where water comes from in a drought situation like California. So a lot of us look around and we think, you see rain clouds up there in the mountain, and we see the ocean out there, and we think that the water comes up from the ocean, goes into the rain clouds, and is dropped on the mountain, and then that's water, and that feeds the land, and that's why the crops grow, and we think that's what, feeds it. So we take our hose and we water things. We water our plants with the hose, and we think, we're helping the garden, we're growing plants with this water. And what that water is in Hawaiian, there's many words for water, but that's called ua, which ua refers to rain falling down. Ua is the rain that comes from the clouds and falls. But the plants do not drink ua. Aole. Ua. What the plants are drinking is vai. Vai is another name for water. You get vai in a river usually because vai, but even when it doesn't rain, the river flows, and that's why it's vai, because what vai is a different type of water that's from the ground, and it's from microorganisms. And even though the rain falls from the ground, majority of that in a forest does not hit the ground. It's absorbed in the leaf layers, and it never, in a true rainforest, the water doesn't really hit the ground. You're on the ground, it's dry, yet it's wet and thriving, and rainforests actually produce rain. You'll see the water comes out of the canopy, goes into the clouds, creates this special water that then rains back and is in this water cycle, but isn't in the ground. So how is that happening? It's because of all the microorganisms in the ground that are using the water hydrology system. That what happens when you get a thin layer like this, or it's dead on the top, is it's very thin and it's very hard. If I take a penetrometer and I try to push it into the ground, and I try to push like a spear into the ground, it's very hard. It doesn't go very deep. Very hard ground. But as that layer increases, as microorganisms start to live in there, they make it aerobic. They bring oxygen down. They bring air down. They bring air, oxygen, aerobic. And that layer gets deeper and deeper and deeper, right? We get 8 meters of soil in some places, deeper even, where that's air going down because there's aerobic microbes in there. And so when the microbes increase that depth and they go down, this air above us is full of vai. Sometimes they get so much humidity in Hawaii, it's 100%. It won't even evaporate off you. There's so much water in the air that evaporation isn't even possible. It's a saturation point. There's so much water in our air. There's an ocean. We're swimming in an ocean out there, an ocean of water. As that layer increases in that depth, the atmosphere can push down. The atmosphere is pushing on you right now, real hard. If you went into a vacuum space, you would explode because you're used to this pressure on you. I'm putting hardly any pressure compared to how much the atmosphere is putting on you, like pounds per square inch kind. And so that pressure, once you get the air, it drives it into the ground. The microbes open up that land, they open up that area. The water in the air comes down into the ground. Now this is vai. It's when you put water from a hose, like on the ground here in front of us, this is ua. It's big particles. It's a bunch of water globbed together, all magnetically charged, floating around, globular wave like droplets. Ua, big ua. The vai in the air, you cannot feel it. Why don't you feel wet? Because it's so distributed, it's not globbed together. It's so fine and mist and single particulate water that's out there that has evaporated, that got this special charge potential to hold it right in the air above us. It's in this magnetic, different sense of water. It's not globs of water. It is water dust of vai. So smooth, so silky. That water is so fine and particulate that when it comes down into those small, tiny holes that the microbes made, that they brought air tubes through, that they brought water pipes through, that when you put carbon in there, It changes the charge particulate. They're able to pull that water out of the air. That vai, the water that comes from the air, not the ua, which is the rain that's too big for them. The ua, the bacteria does eat some ua and breaks it down, but the plants do not drink ua. The plants drink the vai that the microorganisms sequester from the air or process from ua into a fine enough form to put into the plant cell. The plants cannot drink ua. Plants will die if you water them with the hose. They will die because the charge in the water, ua water, kills life. They need the vai from the atmosphere. They need the vai. They need the water from the bacteria, from the akua, from the microbes that process this to feed this plant, to feed this land. So if you want to increase your water in a drought area, do not increase your ua. Do not start irrigating. Do not start doing that. What you need to do is increase your microorganism depth. You need to go from an inch layer, spread microbes on the top, biochar, because that's what helps them pump the water and retain and hold and sequester. Turn this forest right here, all this wood, into char. Put it into the ground. You don't need to put it deep. You can even put it on the surface. It changes how the water works. Then the microbes go deep. As they go deep, look, I took it from, it holds an inch of water. Now it holds a gallon. Now it holds 10 gallons. And as I increase that depth, all that water then returns to the surface of the earth. Why? Because it's not from the sky. It's from the microbes bringing the atmosphere, merging the atmosphere with the ground. As they merged the atmosphere with the ground, then water flows. Water comes out as springs because the microbes collect that water into arteries, just like our blood. They follow those forms, and then water emerges from the earth in springs, in rivers. Vai, not ua. Ua is like its own thing. Vai from akua, from the kane of the microorganisms that live in the aina, that restore the land, that if we want it to return to a wet, rainy cycle that we can collect the ua so we can drink ua, then we can. But the vai is where the life water is, and that comes from restoring the life to the land via microorganisms. Culture them in your area, the indigenous ones. Put the cane viola, which is plant juice, vinegar, and tinctured medicines, and life returns. Forests that support water, rain, life. Pretty simple. So, any questions?
That's a good explanation. Thank you.
So how can we restore the earth? What's the most important thing we can do?
Increase the microorganisms, spread the microbes along with the biochar, and it can be just done on the surface. And the microorganisms are what actually make the vai, which is what can be absorbed by the plants. It's not from a hose, it's the vai.
How are you going to participate?
Spread more microorganisms first and make the solutions to return the earth to what it once was, and thereby greatly increase the abundance for all.
So I tell you the recipes, you know most how to make them. You think that's achievable in like the time frame of, you know, like, are we headed that way? What's your prognosis?
The first thing is people have to want to do it.
So why do you want to do it?
Why do I want to do it? Because I see the need for it, and I do like to grow my own food, and I want my food to be nutritious. I want it to be as natural as possible. But besides that, we're in a crisis of what's happening to the crust of the earth, and that the microorganisms are being destroyed at an exponential rate. And so it's my responsibility as a person living here, as a consumer, if you will, that, it's my responsibility to do my part and to show others for the people that want to, the people that are willing. And if enough of us do it, we can make a huge, huge impact and change from a path of destruction to a path of just the opposite, where everybody can thrive. So it can be done. So I have this knowledge, and just as I have other knowledge, it's my responsibility to share it. It's not my knowledge. It's knowledge that has gracefully come to me. And so I must share with those that want to learn. And the other thing is, it's fun. I mean, actually, it's not laborious. It's not, I don't have a, it's not any kind of punishment. It's actually a really fun thing to do. It's very heart opening.
Yeah, life feels good. Huh?
It feels good that there's a solution too. Instead of looking at what the media would like us to focus on, which is the inevitable annihilation. It's nice, more than nice, to 100% know there's a solution. And that I am part of the solution. Each one of us. Some of us will pick up the calling, some of us won't. Those that will make a difference.